This
Definitely.
conference will now be recorded.
All right. So before we start our class, let's set some you know guidelines for ourselves. So uh, I would like this these calls to go more like informal, not like you're watching a YouTube video. I keep on going and you just listening to it. Um, do feel free to interrupt me. At least, I mean, whenever you have questions. Okay, and let's try to interact as much as possible, but on a contextual basis. For instance, if I'm teaching uh, Linux today, there's no point you asking me about Docker, which is a topic that's going to be covered in the future. Okay, so let's stick to the context, but do talk in this call, do ask your questions, and towards the end we'll try to have some buffer time where you could ask your questions. That could be anything then. But during the class, when you ask me, it would be better, we we switch to the I mean, we stick to the context and talk about only what's going on at that point in time. All right. And so there's no particular order in which I go, but let me try to give you an overview of how I generally take things up. Okay. Let me bring up some notepad. Right. So I generally start by explaining IT architecture. Okay. By taking a simple three-tier architecture. Within this, I try to cover how DNS works and networks. A very 10,000 feet level overview, bird eye view, not in depth. Okay. Networks and firewalls sort of thing, just to bring you folks to you know uh, speed with how the IT architecture works for those who have never worked on it. Okay, then I try to focus on what's cloud, elaborate a bit on it, and particularly on Azure. Then we'll move to the operating system part. Okay, where we talk about Linux and various aspects like file system and all that. Okay, then we'll again learn about Azure networking in particular. Okay, uh, I have one particular session dedicated extensively to networking only. Okay, so this we could do along with Azure networking, because it's very important to understand how networks work in the cloud, not only for Azure but for any general cloud provider. Okay, then we talk about the compute section. When I say compute section, it's about virtual machines, virtual networks, and stuff. Okay, I just don't want to tell you what all we're going to discuss, but just a general flow. Then we'll start a computer sorry one DevOps tool. We'll start with Terraform. Then maybe we'll go to Azure Storage. Then again, you'll talk about Linux disk management when we talk about Azure Storage. Um, then we'll talk about Ansible, which is a configuration management tool. Then we'll talk about Jenkins, which is where you do the continuous integration and continuous delivery. Then we talk about Docker and Kubernetes. Finally, we talk about monitoring. Okay, this would be the flow, and maybe somewhere we might move backwards and forwards. Sometimes we might have to refer to something in Azure networking. Maybe sometimes after Ansible, we might have to do some Terraform stuff, and it would be incremental in the sense that once we go to Ansible, it doesn't mean we leave all these things. We still keep on working on these things with the with the addition of Ansible. Okay, all right. So that's how the flow is going to be. Any questions?
Kiran,
Yes.
will you provide material for all these things, or do we need to take down the notes or something? Because
That's a good
simultaneously
question.
both it won't happen.
Yeah, that's a good question. So I would not want you to take something like running notes, but if there is something that you think needs to be noted down, uh, we will note that down. I mean, you will note that down. Okay. So I have a few documents. Okay. Mm,
Kiran, I have one question, quick question. Do you actually record this session and then send it to us?
yeah,
Or,
yeah. These sessions are recorded. That doesn't
okay.
mean you skip everyday classes.
I'm just asking, do we really
No,
need
I'm
to take
just kidding. No,
notes?
I'm just kidding. Yeah,
Yeah.
yeah. These are recorded. Yeah, these are recorded. Yeah,
Okay, thank
as yeah, I think I should have informed. Yeah, these are recording already.
thank you.
Okay. Yeah, I was just joking. Not that you will skip the classes.
No, that's fine.
All
So
right.
you will send the material, Kiran?
I wouldn't call it material as such, but some ready reckoners. Like I have some files in my GitHub. I can share this with you. Okay.
Okay.
And this is a work in progress. I keep on adding new stuff here, so you can
Okay.
keep referring to this. Okay. I'll share this in our chat window. Uh,
Okay.
yeah, but what I want you folks to do is understand the class, maybe take some pointers in your notes on a notepad or somewhere, and when you practice you recollect from your memory. That's when it will be, uh, induced into your brain strongly. If you keep trying to recover it from memory and practice it, of course you'll do a lot of errors. That's not a problem. Then you can try to Google and understand what's the problem. Okay.
Yeah, Kiran.
Yeah, but there would not be no elaborate, there would not be any elaborate PPTs with screenshots and all. I mean, I can't do all those things, one, and second, there's no point in giving you everything with screenshots, because I would expect you to retain this in memory and practice them and get back to me with questions. All right.
Yes, Kiran.
All right then. Any other questions about the class? So someone asked, where do we cover Linux? We almost cover it in the first or second week itself. Okay, and we will keep coming back to Linux, because Linux is a huge topic in itself. So we'll cover some basics in the initial weeks. Then when we learn about storage, for instance, we'll come about Linux disk management. Maybe after some time you spending in virtual networks and all, we'll come to package management in Linux. So Linux is also again divided, you know into multiple sections. But once you once you come to this stage, every day you need to use Linux, because I would expect all of you to work on Linux machines. Whatever I'm teaching, better practice them on your Linux virtual machines. Okay. So maybe not create a Azure account today itself, but maybe by Thursday you should create an Azure account, and you know then that way you can have the 30 days period from starting from that particular day. Okay.
Kiran, one
So
question.
mhm,
So when you're doing deployments for the Docker images and those things, right? Will
mhm.
you be using Windows as well, or just going to focus more only on Linux? Just
No
curious.
Windows, only Linux. Yeah.
Only Linux. Okay. Just
Yeah.
curious. Thank
Yeah. So I think if you've attended the demo sessions, one of the demo sessions, I told you, right, Linux is the obvious choice for many enterprise sectors. Okay, even for startups or big scale enterprises. uh, Linux is the choice of the operating system. One, because it's very customizable, very extensible, very robust, secure. Okay. And all these tools, for example Docker, would not have been possible without Linux. So is the case with Ansible. Okay. Jenkins, yes, you can run it on Windows. There's not much difference when you run it on Windows or uh, Linux. But the setup and all, we do it on Linux computers.
Okay, Kiran. I
And
missed the demo class. That's the reason, I think.
yeah, no
Uh,
worries, no worries. Yeah, yeah. We're going to focus. I mean, everything we're going to do it on Linux. But there are some things you can do from your local machine. You need not be on a Windows server. For example, Terraform, you can create the scripts from your own computer and run it. Okay. Um, and if you want to use Docker for Windows, you're welcome. Please try that and let me know. I myself have never used it on Windows. Maybe I'll have to do it sometime in the future, because one or the other clients is going to come and ask these things in my regular work. But as of now, I have, and the native support is also not as strong as it is for Linux. Okay, that's for a different day. Let's not skip the topic. Okay, any other questions, folks? All right. Okay, I said we'll talk about IT architecture. So shall we start there?
Yes, Kiran.
Yes, please.
All right. Okay, someone has a question, Venkata. uh, so I would leave it to you. I mean, as I said, this is more like a DevOps course, not a programmer course, but it would have good insights into DevOps, Azure. But that's only one part of this course, Venkat. Not the entire course is dedicated to Azure. So you might want to take your own call. Okay. Uh, yeah, that's about that. All right. So let me ask you all a question. When I hit, let's say, google.com, from the time I hit google.com, I know my network is slow today. And from the time the page loads, what happens, or how do my browser get this page? So I typed in google.com, and after a few seconds, it should be less than that, but I said my network is slow today. It took, I mean, what happens between that time, or how does my browser get this page? Not only google.com, be it any website.
It goes to the web server, it processes your
Mm-hmm.
request, and
Mm-hmm.
then builds the HTML content, sends the
Mm-hmm.
response back to the browser.
Perfect. But how does it know? How does my browser know to which web server it should go? That's the next question. So this is
Okay.
my.
So basically, your IP address should be some kind of DNS routing should be there. So
Mm-hmm.
domain, right? You basically map that domain, google.com, to some public IP address, then figure
Mm-hmm.
out where it belongs to and goes to that
Mm-hmm.
particular location and
Okay.
then connects to that web server. I'm just telling hypothetically.
Brilliant. Yep.
When our
Someone has a
technician
question.
visits your home to do the service,
Sorry, it was not audible. Could you repeat?
Kiran, generally, when you hit an URL, the DNS will
Mm-hmm.
be resolved into a load balancer, and this load
Mm-hmm.
balancer will have either an application server or the web server attached to that. And this
Mm-hmm.
load balancer will redirects to the target listeners, and from there I mean, what do you say, the UI page comes up.
Awesome. Yeah. So you guys almost got it. Okay. But yeah. So my browser, okay, rather not my laptop, my browser. So what it needs to get is an public IP address. Okay. It needs to know which server to go, as some of you said, or a load balancer. We'll talk about load balancer in a minute. So there are some pre-configured DNS servers on my computer. Okay. So it will go to that particular DNS server. But before that, it checks my machine. It checks for my computer, within my computer, if it already has stored the address for google.com. Okay. So it checks my browser, it checks my computer. Maybe I've accessed google.com from a different browser. So it also checks my laptop, if there is a cache in the sense, right, a saved copy of the data, to see if there is a entry for google.com. If not, from my laptop it goes to first. What's your first hop when you're trying to access anything? Where does your first connectivity go? To your router, right? Okay, even some routers have the capability to cache the excuse me, DNS names. For instance, I might not have accessed google.com, but someone in my network, okay, my kid or my wife, someone might have accessed google.com already, so it has came through the router itself. So my router will actually cache it as well. Some routers have the capability to cache uh, the DNS names. Then it actually goes to the internet. From the internet, okay, let's say no one has ever accessed this website, then where does it go? It actually, I mean, when I say ISP, let me be little elaborate here. When I say internet, before that I have someone. Where does it go to? It goes to my ISP. What is ISP?
Internet service provider.
Exactly, internet service provider. It could be Verizon, AT&T. In India it could be Airtel, Act, or various other services. Okay, he has something called as DNS Resolver. Every ISP maintains something called as DNS Resolver. So this DNS Resolver mostly has a wide variety of data, because this is accessed by not only me but hundreds of thousands of consumers. So they might have already accessed google.com. Okay, so DNS Resolver might already have the answer for me and it might give it back to me. If not, let's say it's completely new website, no one knows, so it goes to the internet. From internet it goes to, you know where? Okay, so every website has to be brought from some person, right? So let's say, what's the address of google.com? www.google.com. If you notice, I mean, you might have never noticed, but for every web address there is a dot at the end. Okay, so for every web address there is a dot which we need not write, the browser already understands. Okay, that particular thing is called as root server in terms of DNS. Okay, this is called root server. So this mostly has entries for all the top level domains. What is a top level domain? It could be a .com, it could be .edu, .org. We have a lot of these things these days, right? XYZ, .tech, whatnot. Every top level domain details are here in the root server. Okay, you understand top level domain, right? The last part of your site address, like .com, .co.in, .co.uk, .in as well. A lot of top level domains. So this has all the data about top level domains. Okay, so let's say we are trying to access google.com. So root server says, okay, I don't know this IP address, but I know where this .com servers, I mean DNS for .com sits. So it redirects me to what is called as a top level domain. The root server redirects me to top level domain, TLD. There are a lot of top level domains. For each one there is a server. For .com there is a server. So here also it might or might not know my IP address. Then it says, yeah, okay, I don't know where this particular the IP address of this google.com, but I know where this guy purchased this site from. Okay, so google.com domain has to be purchased by someone, right? By someone, like when Larry Page all this started, they might have bought this domain name. Okay, today if I want to start a website called as kiran.com, I simply cannot start it, right? I have to buy from some folks. Those are called as, any idea what they are called as? Like GoDaddy, Big Rock. We have various Namecheap. So it's called as registrar. Okay, registrar is where you buy your website from, right? So this guy should have our details. Okay, so sometimes these folks, I mean, this guy might not also have our IP address. So he'll say, hey, yes, google.com is bought from me, but he's not managing his DNS with me, but I know where to go. There is something called as name servers. Okay, so he'll say, I know where this guy might be found. Go to these name servers. Okay, he'll send me finally to the name server. Okay, so now this is managed by myself. Okay, either this might be on cloud or on my own data center, but I manage these name servers. Sometimes you have more than one name server to maintain high availability. Okay, availability is not to go down ever. You might have more than one name server, but the record lies the same. I mean, both the places it will have the same DNS. Okay, sometimes this might answer, sometimes this might answer. Registrar will have more than one name server sometimes. And all these things are done by us. For example, this is google.com. Google.com not only enter these values in the name servers 1 and 2, but it's his responsibility to give the registrar these name servers. Okay, if it doesn't give registrar these name servers, what will happen? You will never know where to go to resolve this DNS name. Okay, so these many hops are there. Your browser goes to router, router goes to ISP, from ISP to the root server. Okay, root server to the top level domain to registrar, and registrar to name servers. Okay, some people maintain their DNS within the registrar itself, so this hop might not be there. But otherwise, if someone is accessing your website for the first time, these are the number of hops it goes to, only to get the IP address. Now with all this, what will happen? Let's say name server 1 answered our query, so it will send your IP to registrar. So here registrar will cache it. Okay, so next time when someone gives him a request, he will not send it to you. Okay, he says, okay, I'll cache this up. Then it will send to the .com top level domain. Even again caching happens here. Again it will be sent to root servers, from root server to via internet to ISP.
Kiran, one second. Are you
ISP to
writing
the
anything
router.
on your OneNote?
Sorry,
Uh, you're writing anything on your note? It got
I'm just
frozen in my
drawing it.
screen. Yeah,
I'm
it
just
got
drawing it.
frozen.
What about others? Are you able to see my screen? I mean, see my drawing?
No, now
Yes,
just now I
Kiran.
got it. Now just now I got it.
Yeah.
Yeah,
Okay.
thanks.
So these are the hops we have. So all that to do, not the web page, but you only get the IP address finally. Okay. The IP address of your google.com website. Okay. This happens if it's the first time you're accessing the website. Okay. And if no one has accessed it within your, all the consumers of your ISP have never accessed, or very rare case, but these are the actual number of hops that happen. Okay, and as I said, at every stage when the answer is received, every stage it is cached. So that's the reason every time, next time you access, you need not go to all, you need not follow all these hops. Okay, so your browser knows that it is within your browser IP address itself. Then again, your router caches it. So if someone from your home network accesses again, let's suppose this is an office. If someone from your office accesses, it's already there in your router. Okay, if someone from outside your network but connected to the same ISP access, they have the cache here as well. Okay, if someone from the different ISP, but they'll have it from the root server itself. So that's why DNS is very highly available and highly distributed. It has a lot of caching mechanism everywhere. That's why we don't see much delay in resolving your IP addresses. But only if it's a completely obscure website, no one ever accessed it. Okay, only then you'll have to face through a lot of these hops. But this is also a one-time exercise. All right. Now you understand how DNS resolution works.
Yes, Kiran.
Yeah, cool. So there's a cool video about this one. Just Google how DNS works. The channel name is also how DNS works, I guess, or just DNS, something like that. They'll explain this in a very nice visual way. Okay, so all this we got IP address. Okay, Now let's forget about DNS for a minute. For the first time, I think I draw something that's reasonable. I'll save this. Okay. So yeah, now you got your IP address. What is this IP address for? Your google.com website. Okay. Now, for the sake of simplicity, I'm just drawing it as if there are no other hops, but every time your request goes through your router and router from ISP to the web browser, sorry, web server. Okay. So this is your browser. This is, let's say, Google's data center. And as someone said, it might be IP address of a web server. So my browser makes a HTTP request and this sends a, and Google's web server sends me a HTTP response, and this is called a transaction. And a lot of transactions happen within a single session. Okay. Just for the communication itself, there are a lot of these requests and responses coming up. That we'll talk later when we talk about TLS section. But for now, just understand that your browser and web server are in communication. This is fine. But Google gets lots of responses, right? Lots of questions, lots of what do you call, requests. A lot of people are accessing it at the same time. So they bombard this with a lot of questions. Not only you, a lot of other people. Okay. So this should be a really powerful machine, right? This web server should be really powerful machine. When I say powerful, it has to have a very high capacity.
Hello? Hello?
Kiran, we couldn't able to hear you.
Eline?
Hello. Hello. Am
Yes,
I audible
Kiran.
to you?
Yeah,
Yes,
All
yes.
right.
yes.
Great. Okay. Sorry about that. So where did you all lose me? Right. So I was saying, you established connection to your browser. Let's say a web server. There is a single web server.
Kiran, are you sharing anything?
Yeah, it started. I started sharing.
Oh yeah, now I'm able to see
You
it
should-
now. Yeah.
Okay. So uh, from your browser, you make a request, and the server. Let's call it server, not web server. Okay. Let's say everything is inside this. Your web server, the database, everything is inside it. Okay. So you send a request to the server. Server and sends you a response. Okay. But there are multiple requests coming into the server. In fact, maybe tens of thousands in a minute or in a second to Google. So Google might increase the capacity of this server to a very high configuration, like 400 GB of RAM and 128 cores of CPU, or it could even go up to 1 TB RAM and even like 300 cores of CPU. But one simple uh, funda is that we discussed in the demo as well. Systems tend to go down for whatever reasons. It could be software, hardware, power connectivity, or network connectivity. It could be a simple blip, just like how we got disconnected now. Okay, but it could be a simple blip, but there will be failures. So when you have everything in a single server, what this means is you have a single point of failure, and this is never good for your production grade applications. Okay, I'm deleting this just for now. Okay, so you cannot have a single server, howsoever powerful it may be. You cannot have a single server to handle all your requests. You need to have what we call as redundant servers. Okay, we need to have what we call it as redundant servers. What do I mean by redundant? You have the same setup, not in terms of specs maybe, but in terms of the software and everything. You run the same. For example, this server has Apache to serve me web pages and MySQL to serve the database. Similarly, you have Apache and MySQL here. Both have the same code base and everything. Okay, but these two will have two different IP addresses, right? Every machine will have an IP address. Just take it. Just uh, remember this very well. Every computing device, including your smartwatch, including your router, including your as simple as like a Fitbit, or even your TVs, smart TVs, everything has a IP address. So does your laptop. Okay, so these two have two different IP addresses. So but DNS is a key value pair. Okay, remember, DNS is always a key value pair. What does it mean? That means google.com will have only one entry, one IP address, publicly accessible IP address. Okay, so now I want to have high availability. So I set up two different servers. But how do I maintain my DNS? I cannot maintain two records. So what do I do? So someone has already given answer to this. Who was that? Someone said something about balancing and all that. All right, okay. So we
Load
have something
balancing.
called, precisely, yeah, we have something called as load balancer. Okay, a load balancer is nothing but it could be a server. Okay, or it could be a network device like your router. Okay, but it generally acts as your front end for your uh, devices, and its job, as the name suggests, is to route traffic to various servers. Okay, so again, this also has a IP address. So here in the DNS entry, we don't give the IP address of either of these servers, but we give the DNS of these uh, particular load balancer. Okay, load balancer IP. And remember, every computing device has two type of, not everyone, not every device, but most of the devices have two type of IP addresses. One is private and one is public. Okay, you might or might not have a public IP, but all computing devices will have a private IP. What is a private IP? We'll talk about it maybe in tomorrow's class, but just for the understanding, private IP is something that you could access only within your network. Outsiders cannot access it. Okay. Uh, so I make now my request will not go to the server directly. Instead, it will go to something called as a load balancer. And load balancer's work is only to distribute the load. It will not answer back my question, and it will not send me HTTP web page. It will instead send it to a server. Okay, but yeah, let's zoom into the Google data center further. Okay, so let's say this is fine. Okay, but if you see, we are running both MySQL and Apache in the same server. Again, this is not a good practice as per the IT architecture. The reason being, one one of these services might overutilize your resources, and other one might be crashing. Okay, so your MySQL might be using a lot of RAM and a lot of CPU, and Apache might finally crash. Okay, so you need to separate these two into different servers. So what you can do is you can set up another tier of servers. Okay, here you only have Apache installed on it. Apache is a web server which serves you web pages. So you set up, for simplicity I'm only taking two servers, guys, but there are a lot of other servers. I mean, there might be more than two servers load balanced by your load balancer. Just let me rephrase everything. Even this load balancer doesn't look good. Okay, so you might have more than one web server. Again, this is let me put something like this. I mean, these are not any standard figures I'm drawing, just to differentiate I'm drawing a rhombus here. So this could be your load balancer. I'll simply type LB. Okay, and it will redirect traffic to either of your web server. Okay, now let's come to your DB part. Your data, every application should have a database to store all the data. So then comes your database. This should also be highly available, in a sense this should also never go down. So you need to create a replica of this one. Okay, so again, you make a request to Apache will serve me plain web pages. But if I'm looking for some information, for example like time, okay, or let's say some DNS, I'm looking for some DNS record. Okay, so Google has to go back to its database and get me all these URLs, right? So my first communication is to my web server, but when I make a request to my, when I make another request, I want to understand what's DNS. So Google has to look in its database and send me those requests. So again, Google has to send request to either of these things, but it cannot. Again, Google, sorry, this web server also needs to know which IP address it needs to go. Okay, it cannot simply go to any of the DB servers. It needs to know the IP address. Again, there will be a load balancer in between these two. Okay, so let me put this away. So again, there's a load balancer between these two layers. Okay, so your Apache server, whenever there's a request, it might send it to the load balancer, and load balancer will send it back to your DB, and your load balancer will manage from which web server it is coming, and it will send it to the same web server. So all this is managed by your load balancer. Okay, this load balancer could be a networking device like your router, where you actually put in a physical device, or this could be another server as well, a server which is running Nginx could also do these things. Okay, so more on that later. But if you see, we have two different layers, right? So these things are called as tiers. Okay, so what do we call this? This one we call it as web tier. This one, sorry, web tier, and come on, this one we call it as DB tier. Okay, but this setup itself is not enough, because sometimes there is some computational things that needs to be done. Okay, for instance, based on my settings, based on my location, there might be a lot of computations that needs to be done. Okay, for example, Google gives me highly targeted what do you call, results. For example, if I'm saying hotels at me near me, yeah, so it gives me some results, but these are not universal results, right? I get some results, you get some other results. So it has to do some computations based on my search history, based on my location, and all these things. Okay, this particular part is done through another layer called as app servers. Okay, application servers. Okay, so I'm not sure how I can fit this one. My drawing is really bad, which you might have already realized. So okay, so between your between your web and DB, there might be another set of servers called as app servers. I'm just fitting in here. Uh, okay, so you have something called as web tier, you have something called as app tier, and you have something called as DB tier. Okay, so the way of, so here it runs only simple, these servers are only capable of delivering you simple web pages. So when I say web pages, all these things, right? Like the format, what needs to be shown at the top, the banner, and everything. And then this app server will do all the computational business logic, and everything is processed here. Okay, this guy is from so and so location, so I need to show these locations. So based on this, he will send a request to DB server. Okay, again, these are again load balanced between two or more servers. Okay, so this typical setup is called as, what is this called as? How many tiers we have here? Web, app, and DB tier, right? So this setup is called three-tier architecture. Okay, let me put it in a better way. So this is mostly how your applications have been architected so far. Okay, this is how your architect designs applications for simple applications. But these days, it got what do you call, even more complex, with a lot of other things coming into picture. We'll talk about that. But I just want to help you understand this three-tier architecture. Okay, so just for the simplicity's sake, I'll draw load balancer as a simple line, but understand that that's actually a computing device or a server itself. Okay, so you have your load balancer here. You have one load balancer. Come on. You have one load balancer here. You have one load balancer here. Okay, so this could be how your three-tier architecture looks. Let's look some pretty pictures on the internet, because people draw better than I do.
Kiran,
Mhm.
for more information regarding three-tier architectures and all, what kind of video we need to search for?
Yeah, just Google three-tier architecture. It should get you all the details.
That will be
Okay.
fine, right?
Yeah, absolutely.
Okay.
Okay. So let me see where we can find those things. All right. So sometimes, see, these are all different servers running different set of software. Okay. Here in all these computers, you have a OS. Okay. You have an application. So when I say web server, it's not like something very special. It's like any normal computer which runs Apache. Okay, but since these are running in production, these will be like, very super computers with Xeon processors and high RAM and all that. Okay, everything has an OS and an app. And if your application is very simple, doesn't need much logic, your app can also come here. Your app is also just another software application that can also fit in here, based on how big or how much resources it constrains. But this is not recommended practice. But there are some applications that could combine both web application and the business logic application into a single tier. You might have heard about IBM's WebSphere, and all these things do this stuff, or Tomcat applications also do this stuff. So it's not necessary always you have app tier. Sometimes app tier is optional. Okay, but generally you might have at least two tiers, your web and your database. Okay, and these days you've got a lot of new things, right? For example, when I go to google.com, when I go to google.com, so the minute I start typing, like, let's see, it gives me some instant results, right? So this is again run by another set of servers. Okay, this could be some set of servers called as your instant search, or something running NoSQL. There is another sort of database called as NoSQL. You might have heard of it, right? NoSQL is like MongoDB, and all these are NoSQL. These work different from how SQL works. Okay, so you need to have another set of MongoDB servers. Maybe you need some caching servers where people ask for these questions repeatedly. So you do some caching stuff, okay, like Redis. Okay, and sometimes you might need to have some analytical servers and all these things. So having simply two tiers or three tiers is not enough. So you'll have multiple tiers. Okay, so this part is called as multi-tier architecture, or you might have heard this term, n-tier architecture. Oh, where is it? Yeah, so you have a three-tier architecture or an n-tier architecture. Okay, n stands for any number of tiers. It could have caching, it could have NoSQL, and so on and so forth. Okay, so that's how applications work at the enterprise level. Okay, you simply do not go to one web server, but you go to a load balancer. But that's not the entire story.
Kiran, sorry to interrupt. I have a question.
No worries. Yeah.
So this entire structure architecture, when we correlate with the .NET applications, either in Azure or TFS, how this tier stands it? So the web tier stands at IaaS and app tier as
Exactly.
application servers.
Yeah. Yeah, application could be anything your .NET, anything your .NET application developers develop, something that is inbuilt in your
Yeah,
organization. Maybe they use .NET, but they build their custom code, right? And this DB could be your
database.
MySQL.
Okay. And regarding
Yeah,
this
if
Redis
it's
caching,
Microsoft, it could be MS SQL. Yeah, sorry.
regarding this Redis caching, so generally we are using Redis here to have the token information, right?
Yeah, it could be for your token, it could be for your app caching, it could be for anything. It could be for authentication, also for your application and all that. So when you say token, you're talking about authentication, right?
Authorization token, yeah.
Yeah. So it could be authentication authorization tokens or your app tokens. It could caching is basically like having instant data ready. So these questions are asked frequently. You keep them ready, right? Just like that.
Okay.
Yeah. And NoSQL is the MongoDB, for instance, is a NoSQL database which will not save in the form of tables, but it will save in the form of documents. We'll talk about that later. Okay.
Sure,
When we
sure.
talk about Kubernetes and all. Okay, so this is not itself enough. Okay, so remember, this might sound little complex, but every server has a IP address using which other computers reach to it. Okay, when I say other computers, it could be your own laptop, or for instance, uh, in this case, we call our when I'm reaching to my web server through my load balancer. Okay, when I say my Google's, of course, when I'm reaching this web server, okay, let's say through the load balancer itself. Okay, so here I am the one who is requesting information or requesting something from the browser. So I am called client, and this is serving me page, so this is called as a server. Okay, so I sent a request with some requesting some details about, let's say, DNS, and my web page first serves me I mean the web tier first serves me a web page, and then it redirects me to, let's say, app page. So my web server is reaching out to the app server via a load balancer. Am I right? So I'm reaching to
Yes, Kiran.
my application server from my web server. In this case, this becomes the client, this becomes the server. Okay? So just trying to explain what's server client architecture. That's how you generally refer, right? Client server architecture. Okay. So from here, it will reach to my database for some details through my load balancer. Okay, so sorry, in this case this becomes client. Okay, and this becomes my server. Okay, so this thing varies. So sometimes what is a client could be a server, but your computer could never be a server. Most of the times it could be only a client. Okay, so but these servers act as either a server or a client, but mostly servers. Okay, so that, I mean, server is the name we use for a virtual machine as well, but here in this case we're talking about the role of the machine. It could be a client or a server. So a server is something that serves you data, a client is something that asks for data. Make sense? So that's what we call client server architecture. All right. um, so in this case, let's just tell you one thing and we'll wind up. So how am I reaching to my to the Google servers? Through a load balancer. Of course, load balancer's IP address is updated in the DNS records. So load balancer has the IP addresses of which servers it needs to route. So it will route to me this particular server. But again, within a computer, so an IP address is like a location of your a bank or a some office. Okay, but within the office we have various departments. Let's think of it like a bank. Okay, bank has not only can you mute? All right.
Kiran,
Yeah.
Kiran, one quick question. So, do you have to have, not have to have,
Mm-hmm.
do you have any understanding as on content delivery network, CDN,
Yeah.
where you cache? Okay. So, do you have that concept in Azure? I'm just asking because
Yeah.
you have not
Azure
mentioned
has
that
CDN.
here.
Yeah.
So,
Azure has CDN.
okay. Just curious. Okay, cool. Thanks.
Yeah. Cool. That's a good question. All right. So your IP address is the like location of your bank, but within the bank you have multiple functions, right? You have something called as front office or reception, Even before reception, you might have something like a quick help desk where that guy will ask what's your request and send it to the particular department. So similarly, in the application, in the server itself, every application runs on a specific port number. For example, IIS runs on port 80 or 443. For example, if you're running an application, a custom code on .NET, it could run on 8080. Okay, and your DB, for instance, MySQL, anyone knows on which port it runs? It runs on a port called as 1443.
440.
Sorry, 443?
Yeah, that's what I was
1443?
7. 443.
Yeah, it's 14.
440.
No, 443 is HTTPS. 1443.
Oh, it's 1443.
MySQL. Yeah. So if it's MySQL, it runs on some other port. If it's a mail server, so a server could be a mail server or a web server. So a mail server runs on port 25. Okay. So this is like where exactly your service is running within the server. Your port number is the specific entry point to access your server. Okay. So you have to give that information to your load balancer as well. Say that, okay, I need to reach on port 80. But when I'm typing my address, I'm not giving anything, right? So how does the load balancer know I'm reaching on, I'm asking for port 443? Because these are default ports. When I'm using my browser, it notes, the browser says that it's an HTTPS request. Okay. So it knows that, or rather it's a standard, industry-wide standard, that for HTTPS means 443. That's why I need not mention 443. Otherwise, every IP address is its domain name colon followed by, sorry, its domain name colon the port number. But we need not give this because your browser implicitly understands that, okay, he means 443. So it will automatically send it to the 443 port itself. Okay, so I send to the 443 port on load balancer. Your load balancer might send it to any of these ports, either 80 or 443. Okay, and from here, when I want to reach the application, you write in the configuration that it has to reach to this particular server or this particular load balancer, and from there it has to reach port 8080. Okay, so the ports are like point of entry for your service, but you cannot let everyone enter to access all the ports. For example, if you enter a bank, you let people only enter till the teller point of teller desk. You'll not allow someone to go beyond your teller and go to your manager or storeroom, right? So for example, if I want to access this computer, there's another service running called as SSH on port 22 if it's a Linux machine. If it's a Windows machine, there is something called as RDP, which is running on 3389 port. These are like various departments in your office. So you will not allow someone outsider to go directly into SSH, right? Meaning to the cache room, right? So you have to restrict people to access on only a certain port. You need to see what the request is for, and if someone is trying to enter into my computer using SSH or RDP, I need to restrict them. So how do I restrict them? I restrict them using something called as, any idea what is this device called as, which restricts people from entering on specific ports?
Firewall.
Firewall.
Precisely, yeah, firewall. So we have a firewall device before even you enter your load balancer. Why do we need it? It's like your security guard. It asks, it stops you and asks, what is your request for? Is it for a web page? Uh, yes. So it's either on 40 or 80. So it will pass your request. If you're trying to send a request for SSH22, it won't. Okay. You might ask, Kiran, why do someone come to port 22 on a web server? Because my web page is served on 443. But why do you want, someone wants to enter into 22? Because they want to exploit your server. They want to enter your web server and steal some details or corrupt your computers. So SSH gives you the ability to run commands on your computer remotely. So that's a danger, right? So your firewall will stop that request. But what about people within your office, within the Google network? Let's say there's an employee who wants to troubleshoot something in this computer. If you're blocking him on port 22, how will he go? So you can write rules on firewall which says that if the request is coming from within the network, okay, it can be allowed to access port 22. Okay. So if someone is coming from outside, suppose I am trying to access the Google server on port 22, this connection will be dropped at the firewall stage. Okay, if someone internally coming to firewall and asking he needs to access on port 22, he will be given access. But this is only the network route. Authorization is the next part. Next part, he will need to enter his credentials for authentication and authorization. Firewall only prevents you from entering specific ports from specific IP addresses. So if it's an internal IP, it will allow you to connect to port 22. If it's not, it will not allow you to connect to port 22. Similarly, some people use firewalls even between various layers. Even though it's internal only, they want to be extra cautious and put firewall between these layers as well. Okay, and they will allow only the traffic to flow from this server to this server on port 1443, and this server to this server on 1443, and rest of the servers cannot even access these servers. Okay, so this is how you could securely harden your infrastructure. Okay, so this is what firewall is, and what is the equivalent concept of firewall in cloud, we'll see later, but just for your understanding, I'm giving this.
I have a quick question. You just used the
Yes.
word called harden. What does that mean?
Sorry, what?
Harden. I mean, I've
So
been hearing
make it,
harden.
yeah. So making it hard for people outside your network to attack your computers. That's called hardening. So from a security perspective, when you harden something, like you harden the walls so that no one can break it. Similarly, you harden your infrastructure using firewall rules.
Okay, makes sense.
All right.
Thanks.
Thanks, folks. And I know you might have questions. I'll repeat this with a better diagram hopefully tomorrow. And we'll talk about CDN and public and private IP addresses and networking stuff tomorrow. Okay.
All right, thanks.
Thank you, everyone. Have a good day. Stay at home. Stay safe.
Thank you.
Kiran,
Thank you.
Yeah. Yeah. Go ahead, Kirti.
Kiran, will you share the recording now?
Career IT folks will share with you.
Oh yeah, sure.
I
Thank you,
will
Kiran.
be sharing the recorded session after an hour or so. So please wait till 10 o'clock so that it'll get recording. For all, I'll be sharing, okay, today's recording.
Yeah.
Okay.
Thank you.
Thank you.
Sure.
Thank you.
Pray. Enti?
Yeah, pardon? Someone is asking something? Hi, someone is asking something?
Hi, this is Sanjeev. I needed some more information about the course. How do I get in touch with you?
Sure. We'll be talking to you. Okay, if we have shared all your details, we would be talking with you. Okay, maybe by tomorrow also you'll be getting a call from us. Okay, and we'll coordinate with you on this, and we'll be giving other details as well, Sanjeev. Thank you. Yeah.
Thank you.